Hello AP Calculus. I'm coming back with section 1.3, and this is the start of probably a slightly more lengthier review process for all of the trig stuff we learned last year. Clearly we can't dive as deeply as we did in pre-calculus, nor do I want to. I think that for this course you need to know, well, I'll unpack what that means for this course, but today's going to be mostly just unearthing, or not unearthing, but just reminding you guys of kind of the stuff that was simple about trig, and we'll see how far we get with these videos. So, textbook isn't available right now, so I'm just going to put these on the board and see where it takes us. So converting degrees into radians and radians into degrees. There was a ratio between the two where pi radians over 180 degrees, that's basically the unit measure in which we can go back and forth between the two. So if you're trying to go from degrees to radians, you kind of want to cross-cancel the unit of degrees. The 180 would go on the bottom and the pi radians would go on top. So you'd multiply this by pi over 180 degrees, this by pi over 180 degrees, and the same for the other two as well. Over here, you would do the opposite flip. You would say 180 degrees over pi radians, we'll take a radian measure and convert it into degrees. So you're going to take this times 180 over pi, this times 180 over pi, this times 180 over pi, and the same thing here. You can pause the video and try to do all these at once. See if you can do it without my help. All right, you've unpaused it. Let's see if you got them right. This ends up being 5 pi over 6 radians. This one turns into 2 pi over 3 radians. This one turns into 5 pi over 2 radians, and this one is negative pi over 3. All I'm doing is cross-canceling and reducing where I can. Make sure you write these in terms of rational fraction, 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 fraction. Don't use decimals put side by side with pi. It's just not an elegant solution, and really I want you guys to keep up your fraction skill set, okay? On these, you've got, let's see here, 120 degrees, 150 degrees. This is 135 degrees. And this one ends up being negative 630 degrees. All right, pretty basic stuff so far. I'm going to teach you something new, kind of weird directions. Number 15, check it out. Not 15, 5. Find the length of the arc that subtends a central angle theta on a circle of diameter d. So let's just draw out the situation. So here's a central angle. They're saying that this theta right here is 50 degrees. Hopefully you guys can see that. So we got 50 degrees right here. Oh, shoot. We want to know what the length of this arc is in terms of radians. The way we can do that is using the formula that it's called S equals R theta. They're basically saying the arc length, they call it S, is equal to the radius length times the central angle. So the central angle right here is 50 degrees, but they want it in terms of radians. So the first thing we're going to do is say, well, it's 50 degrees times pi over 180 radians, which gives us 5 pi over 18 radians. That's what goes in for theta to start with. They give us a diameter of 16, which means our radius is only 8. And then we just multiply. Now I can put this over 1 and cross-cancel the 8 divided by 18 and get 4 over 9. That would give me 20/9 pi. And there's probably a decimal approximation in there as well. I'll just keep it at 20 pi over 9, though, and tell you to multiply it out if you want to see what that decimal is. If you want some more information, what I would do is I would kind of Google some of those directions and just kind of see like what some of the other sources are saying about it. And check out in the textbook for this specific example. They talk about this on page 28. So if you look on page 28, they kind of explain this idea of what all of that word usage actually means. All right. I'm not restarting this video, guys. It's been a long day. Okay. Number 7 should be a familiar sight. When you see a 30-degree angle and we're trying to determine what x and y would be in this case, you should be thinking of the 30, 60, 90 kind of right triangle situation here, where there was a relationship between, if you had a 30, 60, 90, then you know that the opposite side is sort of like 1 times some factor, right? I think some teachers use the letter W to denote that. Yeah, I'm going to bring you guys closer so you can see it better. There you go. And then this side is 2W. And then this right here would be root 3W. So they're saying this works every single time. So if you know that the side opposite of 30 degrees is 4, what you can then do is say, all right, 4 is equivalent to the 1W side of the generic 30, 60, 90 right triangle. The hypotenuse is always double what that opposite 30-degree side is. So the hypotenuse of this triangle is double 4. Okay? Furthermore, they're saying that root 3 times that scale factor, whatever that might be, that W, is going to be this side here. So 1 times blank gives me 4. 1 times 4 gives me 4. So that W is actually going to be 4, and this one's going to be root 3 times 4, or 4 root 3. So I guess make sure that you guys recognize and remember like this ratio for a 30, 60, 90 right triangle, which is also a 60, 30, 90 right triangle, just based on what perspective you're using. And I'll also remind you guys that a 45, 45, 90 triangle similarly has this whole idea of a 1, 1 root 2 relationship between its sides. Yeah, I can put W's in there. It's like, I think you guys understand. Ask me questions if you don't. All right, so we've got odds 1 through 7, pretty solid. We're rolling along. Let's just keep this wagon train rolling on to Oregon. Ugh. Sorry, bad Oregon Trail references there. All right, number 9 says, find the values of the trig functions of theta if you're given an angle for sine and tangent. Maybe I'll do both of these. Maybe only one's necessary. Okay, so if you're looking at number 9, they're saying sine is 3/5. Number 11, Tangent is 5/12. All right, now they seem to be very specific about this. They're saying theta is an acute angle, which means it can't go past 90 degrees. So we can't talk about an angle that rotates all the way over here and maybe creates a sign that exists in a different quadrant. Now, the sign would only be positive in 1 and 2, if you recall. The tangent would only be in 1 and 3. They're basically saying you're stuck in quadrant 1. So if we're stuck in quadrant 1, let's draw that acute angle for sine right there, that theta. Talking right triangles. Sorry, I got to make this much bigger for the video to work. Okay, pretend like I can draw a right triangle. So just remember your ratios. Sine is opposite over hypotenuse if we're talking about with relation to the angle theta. So opposite is 3, hypotenuse is 5. Cosine would be the adjacent side to theta over hypotenuse. And the tangent is opposite over adjacent. Cosecant, secant, and cotangent are just the flips of these ratios. We might see those soon. All right, so this first one, to find all the values of the trigonometric functions, I guess they're talking about all 6 trig, all right? We need to find that unknown side. So use the Pythagorean theorem to say 3 squared plus, we don't know, I'm just going to call it b squared equals 5 squared. Which gives us 9 plus b squared is equal to 25. Solve the equation like you know how to do. Subtract the 9 equals 16. Square root both sides. You get b is equal to 4. All right. Once we get 4 right here, then it's just a game of sine of theta we know is 3/5. Its flip, its reciprocal is cosecant. That's just 5/3. Cosine is going to be adjacent over hypotenuse, which is 4/5. Its reciprocal is secant. Tangent is opposite over adjacent to that theta. And cotangent is just the reciprocal of that. Yeah, so why don't you do this? We got that there. Why don't you, if you really want to get some practice in this, pause and try number 11 on your own. Okay, let's see if you got it right. Opposite over adjacent, 5 divided by 12. I happen to remember that this is a 5 to 12 to 13 perfect, like Pythagorean triple. All right, so I can kind of like go to the front of the line here with that problem. That gives me all the trig right away without needing to use the Pythagorean theorem. It would have been 5 squared plus 12 squared equals c squared. 25 plus 144 is 169. Square root that and you get the 13 right there. Sine ends up being 5 over 13. Cosine ends up being 12 over 13. We know what tangent is, 5/12. And then cosecant, secant, and cotangent are those flipped.